Hi there. I've done a number of videos of ThingWorx performance monitoring with Grafana and Prometheus. There's a slight problem with that approach, however, and that is that not everybody has it set up. So today I wanted to have a look at something on a bit of a pathway that's more of a lighter approach that leverages log files that we either have set up already or can easily set up. So previously we looked at utilization subsystem metrics and how the utilization subsystem metrics can be exported and imported to an Excel workbook that I created to kind of tear those values apart and make something of it. Today we're going to have a look at a very similar thing that adds somewhat of a time dimension to that using the Tomcat Access Logs. Now, as ThingWorx is running in a Tomcat web application server, this means that we can add a few additional Tomcat parameters to the log file so that the access logs will include the HTTP status code of the response of that HTTP call, as well as the service execution time, how long it took for the Tomcat to be able to process that response and return it to the client, and the bytes sent back to the client. So that's three additional pieces of information above and beyond the standard ones that are going to enable us to essentially tear apart the URL and get some relevant ThingWorx related information about which services are being called from outside of the ThingWorx platform, like mashups, APIs, other systems, and looking at some things like data transfers, calling hosts, and the like. So let's have a look. Review. I'm going to try and do this quickly. First of all, Tomcat 9 configuration. You need to change your server.xml, access log, valve. You've got a number of values here that are going to be included in the configuration as default. We need to add three of them. We need the status, session code, we need the service execution time, and we need the byte sent. So something like capital B, and somewhere in there, time taken to process the request in millis. Right, that's going to come in the log file. Access log is going to look a little bit something along these lines. Host IP, date time, method, URL, protocol being used, HTTP 1.1, status 200, 9942 is the size being returned. 1 and 2 here is the time taken to execute the service. You can see here that I have an 8-second. It's coming up with a 6.6K response. And this is essentially what we're going to tear apart in Excel, and we're going to do some cool stuff with it. So let's have a look at the workbook that I've built to essentially import that using Power Query. I will say the workbook has been giving me some issues. I don't know what's going on in Excel. This is 18 megs. And there's a fair amount of data in here. There is a data table and a couple of pivot tables, so it might be too much, but we need to enable the content here. And let's go over to the data section here, get data Power Query. We come down here and we say data source settings. We're going to change the data source, change file path because you've likely got a different access log, or you might want to select a specific date. One of the reasons my file is so big is because I have 4 days of data in this access log. I've concatenated 4 separate files together into one. And so I have just chosen that file that contains 4 days of access log data. I can hit refresh all. It's going to refresh it. It's going to reread the file, reparse all the columns and everything, and bring it in. You'll see it's got 9 columns that are accounted for in the import. You could probably insert a blank one in here if you wanted to import more columns. The key is that these are named, right? So this is a table, and the rest of the columns over here are named. Timestamp, month, day, hour is just a reformatted view of timestamp so that we can have month, day, so that we can then do aggregation based on those increments, month, day, hour, because that's what I want to look at in my pivot tables data is the hour column. And this is services, just searching for /services/ in the URL. And if it doesn't find it, then it's considered that it's not a service. The purpose of this is I'm not really concerned about the static resources that are being loaded here from a performance perspective, although they're taking up bandwidth, they're not taking up really platform resources, so I want to get rid of those. And you can see here that just by starting to do a bit of analysis, only looking on those service calls, now you can see the service calls across time. If I come over here a little bit and see timestamp, I can see the second increments, and I can see the calls of only the services. And the entity context is really looking at what the caller is, what the class that's calling this is, session info, we've got some things, common thing, and then I break it down into the service name. The service name is really the focus, added in the status code. Normally you should see only 200s, but here we do see that there is effectively, there's a server exception error that's being returned here on the recalibration of the differential afterburners, which is important to note, of course. Service time and return bytes are really the focus, right? I want to do a multi-dimensional grouping using a pivot table on the service name across the time. This is this month, day, hour, so I can look at hourly services across service time and return bytes just to make sure that those are correlated. And the time is going to be the most important thing, but just even to start, just to kind of show you that this can be quite valuable even without looking at the chart, just to do some stuff like greater than or equal to like 5 seconds. If I put a filter on the service time column, then all of a sudden I can see a list view that is ordered by time. Right, so I can see the progressions of when these services are being executed. You can see here it's quite frequently, and how long they're taking, right? 6 seconds, 10 seconds, 6 seconds. So this is the kind of level of granularity of the execution flow of things that is just not possible for us to see with utilization subsystem metrics. It gives us a different view. It's not what's happening inside ThingWorx. It's what is being called to ThingWorx from the outside, like a mashup. And that's the case for this Git plant area overview. So here it's looking like there's some optimization that we can do on this Git plant area overview, not only to make it go faster, but also to make sure that it's called less frequently, because here it's twice a minute. It looks like 3 times a minute, taking a fair amount of time. Let's look at the summary data. So using pivot tables, as I mentioned, just to pivot across the services up here, and really grouping by the top services based on the cumulated sum of service time, and looking at this across the hourly periods. I haven't updated this yet. Refresh, I should be able to get rid of the 3rd of February. Normally I've removed those from the data set and should only have the 4th and 5th and 6th of February. And there's 4 of them or so just that are used to build up the various graphs that I have over on the dashboard page. So the dashboard page, it's possible I didn't refresh the data. Dashboard page, the one thing I will mention is this selector. This is a time selector that you need to make sure is lined up with your data. Here I'm seeing the data only because my data falls in that period, but you will see empty graphs and empty summary data table if this timeline selector is not selected to your data set. So what's kind of neat about this is you can use this to kind of select out periods. So here I'm just going to look at a few days, and I'll add one more, get rid of that really tall bar. But here I can see that I've got groupings across a few days that are showing me that I have essentially 3 services that are from an external to Tomcat perspective, consuming the most execution time. And this particular one that we just saw on the other page, Get Plant Area Overview, is 370 odd, I was going to say seconds. Yes, seconds. So considerable amount. And there's these other 2 are related to report generation. So these are definitely areas that I should be looking into. I would say something else to look into here clearly that we're seeing is this outage that's happening here, and the fact that none of this is really flat, right? It is kind of curious. We should expect to see these types of things that are relatively flat, but it's clearly not, right? It is quite variable. I don't know why that is, but it is variable. I also just wanted to look at, this is a ThingWorx services focused view on all of this with our top services and their participation and execution time. Here we're looking more at just Tomcat view of things. The service time execution overall in orange, the blue is the bytes. We can see that there's a couple of patterns where the spikes line up. Otherwise, we got this outage. And as we kind of come down, this is also interesting. Number of requests by hosts, just to sort of see the different clients that are communicating with Tomcat. We can see that the majority are coming from this yellow host, 10.0.3.5, whereas there are a couple of others that are periodically, not very much. There's a couple of calls here. There's a number of requests, 696 calls on the 4th, and 802 on the 5th for that IP. And just byte sent correlates quite nicely with just the number of requests, as well as the response status codes. I put the response status codes in here as I did see some of those 500s in there, and just wanted a way on the dashboard for us to quickly identify if there are any areas where there's particular errors that are coming up. And here we see at this point on the 5th of Feb that there are 61 404s that we could go and dig into if we wanted to. So this is just kind of a quick and easy tool to be able to use to start to do some ThingWorx performance analysis. Here we're talking about Tomcat service execution in ThingWorx, and the reason this is relevant is we call stuff too much. If it's already a long-running service that's called too frequently, then it's going to have essentially exponential impact on the ThingWorx platform, and hence why it's important for us to really know what's going on across time. What types of things are adding up? Do you have timers that are adding up? Do you have external systems that are calling into ThingWorx and doing things like we saw here on the end? This is an external system that is having a really big impact on the system at that particular moment in time. Purpose of this tool is to try and give people that are using ThingWorx some easy tools to use with just logs and things that they can get access to without setting anything up as far as monitoring systems. I hope it's been beneficial to you and will be. And please leave any remarks or comments that you feel so fit as far as ideas that I might be able to improve or look to add on to other types of analysis tools like this, which could be beneficial. I've been thinking about this morning about a particular colleague and some performance optimizations that he's done recently on some applications that really just involved having too many service calls from mashups and other UI interfaces. And the too many meant that it should have been 1, but sometimes it was 3, sometimes that would be 5. So multiplying what should be 1 by 5 when there's DB implications and memory calculations behind it can be huge performance improvements. So I'm conscious that this view is only looking at time and not quantity. So added another one right below it that, look at this, it's counts. So not specific counts that we're going to see here. Number of requests by host. These are overall HTTP requests by host. This list here is same as above, but it's counts of service executions. And there is a sort of unfortunate thing about this view is that we're looking at top 10 of each. So we're not seeing the same thing. This is top 10 amount of time spent in these three top services, whereas here we're looking at the top counts of services, and you can see that get property values comes out in that. These other ones do come out, get plant overall list that we should see over here, right? Get plant area overview. Okay, so it's not exactly the same, but we see some similarities, but it's not the same source data because of the fact that top count is not the same as top time. So if we come over here, I added some coolness to this. Keep in mind you're going to break the filters that are on there when you use this. I have put some explanations here as far as how to put it back on, but if we wanted to pick a few of these, like let's get property values, get plant overall list, get style definitions, there's a bunch of gets we can get. Okay, right, I forgot to do multi-select button. Okay, looks like it's checked, and that's why it didn't clear. Normally it should clear the list on the first selection. Okay, so there we go. We got the first selection, and then we click multi-select, and then we can say get plant overall list, get property values. All right, so we chose a few of the gets. Oh, the compliance report. There we go, we added a few more. Now when we come back to the list, you'll see that that slicer on the service has just aligned the two of these together. So we should, colors are not going to be the same likely, but get property values. We are going to see now the same data sources being applied to these two charts. So you can use this approach as a level up. Let's just say if you're looking at optimizing and understanding the performance and usage of a few key services. So you can pick one or two of them in here, and you'll have those reflected over here. So now we just have those four. And so I couldn't leave it alone, and I was thinking about the fact that, okay, that's great, Craig. Now I can see how many times they were executed and how much time they spent, but what about the evolution of the average versus the maximum times, which is very significant depending on potential congestion that we have. So I created another thing over here, and let's just kind of have a look. This probably get plant overall list is a good one to pick. Created another version of the pivot table, which is for use to go into detail. And going into the detail is specifically the minimum, maximum, and average plotted tied to the service name. So right now I think everything is selected. So these are the overall minimum, maximum, and average execution times in milliseconds over here for all of the services. But if I want to see that understand for my particular data period that I'm looking at here, and I wanted to see that get plant overall list, wow, look at that. So here I can see that I've got some very significant max spikes that are showing up here, and pretty flat average and a pretty flat minimum. So this is kind of perfect as far as service execution analysis that I wanted to do. That I can't see in the utilization subsystem metrics is that I can see that the max execution time on the service get planned overall list here is okay. It's obviously much larger than the average, but here we can see that it is extremely spiking. So this is indicating that there's some other form of performance related issue that's happening at this particular time. If I do look at some of the other ones that get property values was one of the most commonly executed ones. And you can see here the max and the average are quite close together, but same here we see two crazy spikes for get property values that might indicate something else is going on. Okay, we're going to stop there, and I'm going to leave this spreadsheet alone. I think it's already pretty darn good. I guess I forgot to mention how to get to the top lists back. So let's just quickly have a look at it. Top list, if you come over here, you have to find the two related tables for here, and we can just right click on here and say filter top 10 items, some of service time. We'll get our top list back there on that first one, and we got to kind of scroll over a ways to find the other one here, and we'll do the same here. Filter top 10. Okay, so now we'll get a top 10 view on both of these. All right, enjoy.